How does stress orientation affect frac spread? Hydraulic fracking is highly dependent on the in situ stress state of the mother rock. Fractures are a tensile failure of the rock and form perpendicular to the minimum stress direction and generally propagate in a vertical direction following the path of least resistance. Horizontal wells allow us to locate our perforations and fracture zones for optimal contact with reservoir rocks and propagation of fractures. The goal is to keep fractures in the zone and reduce the cost of jumping out of the zone. The relative magnitude of the in situ stresses and their direction affect fracture propagation and production. In situ stresses also influence well bore stability, permeability, and the direction of gas flow. Hydraulic fracturing changes the in situ stress state of the mother rock. Stress shadowing is the zone affected from previous frac stages. Changes in minimum horizontal stress can be great enough that it will alter the fracture initiation, position, direction, and length of propagation in subsequent stages. Spacing of hydraulic fracturing is key for optimizing productivity. Tighter spacing can reduce hydrocarbon production per stage, but a potentially self-correcting process is where stress, pressure, or flow can escape through the fractures, propagating into adjacent zones. The danger is having our fractures propagate outside the zone of interest, resulting in lost production, remedial work, and the cost associated with pumping more frac stages than needed. Microseismic and other physical and mechanical in-hole measurements can optimize our cost-benefit ratio. Modeling and reservoir simulation is key to understanding these factors and are vital to designing well completions that ensure maximized well productivity.